It's a huge question, right? I mean, as these AI models get smarter and more complex, the financial and environmental costs to train them are just skyrocketing. We're talking millions of dollars and massive carbon footprints just for a single foundational model. The demand for raw compute power is totally outpacing our hardware improvements right now, and that creates a serious bottleneck.
Part 1. The AI Training Bottleneck. The Heavy Backpack. To really picture why training is such a resource hog, imagine a hiker trying to climb a steep mountain while carrying this ridiculously heavy backpack. That heavy backpack is what engineers call vanilla backpropagation. In standard AI training, the system is forced to hold on to massive, full-rank data tensors just to learn. It's literally like forcing our hiker to carry an entire multi-volume encyclopedia up and down that mountain just to check a couple of facts. It eats up massive amounts of memory and effort.
Part 2. Enter the instant framework, compressing for scale.
So this is exactly where our source research comes in with the instant framework. The secret sauce behind it is this brilliant mathematical technique called low-rank projection. Basically, it's compressing complex data into a much smaller, essential summary. Going back to our hiker, instead of carrying the entire encyclopedia back and forth, they're just carrying the index. It keeps all the critical information, but the sheer weight on the system is drastically reduced.
And you can see exactly where that weight gets dropped. Looking at the architecture of the instant framework, the green path is the forward pass. Those black arrows dropping down, that's instant saving a tiny, compressed version of the data into memory instead of the massive full version. Then in the red backward pass, it just runs its computations using those compressed summaries. So it's saving memory exactly where the heaviest lifting usually happens.
Part 3. Squishing the data. How it works. Now you're probably wondering, if we're just throwing parts of the data away, doesn't that completely ruin the AI? Well, no, because the framework solves this with a really clever calibration process. Every so often, it pauses, analyzes the data, and applies a 95% energy threshold, meaning it tosses out the noise but meticulously keeps 95% of the core information. And just to be extra safe, it uses oversampling, which basically means keeping a tiny bit of extra padding in its summary just in case it needs it.
What's really interesting about this is seeing the visual proof of just how compressible this data actually is. Looking at a layer from the popular AI model BERT, to hit that 95% energy threshold, the system only needed 6 data points, just 6 eigenvalues. It totally proves that the vast majority of standard AI training data is just redundant noise holding the system back.
Part 4. The main outcomes. Measuring efficiency. Okay, if you're making policy or funding decisions, the math is cool, but you care about the ROI. And the researchers delivered a massive 15 times reduction in computational cost. That is 15 times fewer mathematical operations required to train the model. In the real world, that translates directly to a plummeting electricity bill, way faster training times, and significantly less wear and tear on your expensive hardware. But actually, it gets better. They achieved a mind-blowing 32 times reduction in activation memory. Memory is almost always the biggest, hardest roadblock in AI development. I mean, if a model doesn't fit on your graphics card, you simply cannot train it. By shrinking that memory footprint by 32x, Instant is allowing massive models to be trained on standard, much cheaper hardware. It's a real game changer.
You can really see that ultimate ROI when comparing standard vanilla training directly to Instant. The compute requirements, the MFLOPS, drop from over 14,000 down to just over 1,000. The memory falls off a cliff from 13.5 megabytes per sample to less than half a megabyte, and the absolute kicker is that final column, accuracy drop. All of these incredible efficiency gains happen with only a negligible, roughly 1% drop in model accuracy. You're getting the same AI for an absolute fraction of the cost.
Part 5. Greener, accessible AI. Lowering the barrier.
The broader implications of this are just huge. This isn't just about saving the big tech giants some money. So the crucial point is actually democratizing AI development. The researchers prove this by testing Instant on a standard Raspberry Pi 5, literally a tiny $60 computer. And as you can see with the blue Instant bars compared to the red vanilla bars, it heavily cuts total training time, right there on a cheap edge device.
We've seen how compressing data through some really smart math can practically shatter the hardware bottleneck of AI training, and it leaves us with a pretty powerful thought, especially for those of you steering the future of this technology. If we no longer have to spend 90% of our budget just keeping the server farm running, if we can train models 15 times cheaper and with 32 times less memory, what kind of incredible, accessible breakthroughs are we going to build next?